Welcome to qnawire.
Hi, so in this case we're going to have a 0.15 molar solution of trimethylamine. So I'm going to abbreviate as trimethylamine, which has a value for Kb equal to 7.4 times 10 to the minus 4. This means that the value for pKb is going to be equal to minus the logarithm of Kb, which turns out to be 3.13. At the same time, we know from the relationship between pKa and pKb, which is that pKa plus pKb needs to be equal to 14 always. From here we can calculate the value for Ka, which is going to be 14 minus pKb, and the pKa for this compound is going to be 10.87. So in this solution, we are also going to have a concentration of 0.26 molar of 3-methyl ammonium. So what we have is a weak acid and its conjugate base present in solution at the same time. So the way to calculate the pH for this solution is with the Henderson-Hasselbalch equation, which tells us that pH is equal to the pKa plus the logarithm of the concentration of the conjugate base, which is normally abbreviated as A minus. In this case, the conjugate base is going to be neutral. I'm just going to keep the notation for sake of how things are usually done, and HA, right, which is going to be the weak acid concentration. For us, these values corresponds to 10.87 as the pKa plus the logarithm of the concentration of the conjugate base, which is 0.15, divided by the concentration of the weak acid, which is 0.26. The result for the pH is then 10.63, which is more acidic than the pKa of the compound. This makes sense because we have more of the weak acid than we have of the conjugate base. That would be all. Thank you very much and have a good one.